the existing tools today often lack the same kind of engineering effort that you would see in like tools from like that are like built into Linux. And I think some of that is like kind of been missing from JavaScript.
Hello, welcome to the devtools-fm podcast with a special message.
A few episodes ago, we talked about the podcast in a meta episode and sort of how it's grown. As we're trying to scale it out, we find ourselves at a position that it's going to take a little bit of funds to grow it how we want. We want to deliver more content on a more consistent cadence, and our format is going to need to change a little bit.
So we plan to have most of the episodes still free. We still plan to provide a free podcast, but that podcast will be limited to probably around 45 minutes and will be a shortened, more condensed form of our interviews. The full episodes will now be hosted on Patreon. You'll be able to find an ad-free, full-length version of the episode. But we really still intend for the free podcast to be a quality product that you still want to consume.
Yeah. Hopefully this will give the sort of best of all worlds. We're trying to navigate this carefully to figure out how can we make the podcast more sustainable and grow it while also having a quality experience if you're just like wanting to go on a walk and listen to a podcast. So there's a few other things that we're going to start doing. So if you subscribe to Patreon, you'll get access to our Discord server. We're going to try to have all of our speakers who have joined us in the past on there. And then, of course, like other Discord setups, the higher level roles comes with more perks. Like maybe you can get involved in helping us choose who to interview or be involved in planning the episode itself. So we're still kind of working on the details, but plenty there.
The Patreon is live right now, so if you're interested, the link will be in the show notes. We do have a plan that if we hit $1,000 a month, we'll be able to scale the podcast up to a weekly podcast. So that's our initial goal. So I hope you all join us. We're very excited for this next chapter in DevTools-fm.
Yeah, thank you to everyone who has listened and supported us. It's been a really, really fun journey, and we're excited to grow it further.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, our guest today is Jarred Sumner. Jarred is the creator of Bun, a JavaScript runtime that also has a built-in bundler, transpiler, task runner, and dependency manager. I'm not sure if I forgot anything there, but it's very expensive. Incredibly ambitious project, and the performance numbers coming out of Bun are incredibly exciting. Jarred, really, really great to have you on. Super excited to talk about Bun. But before we start talking about Bun, could you tell our audience a little bit more about yourself?
Yeah, a little about my background. I dropped out of high school when I was 16, joined a startup, then did the Teal Fellowship. Just before the Teal Fellowship, I did the first open source project I did that had some traction was this crowdfunding platform called Self-Starter. Startups raised around $10 million with Self-Starter. At the time, there was like this, this was in 2013, I think, 2012, maybe it was 2014, somewhere in that range. It was starting to become a thing that hardware startups it was like a brief rebirth of hardware startups, and they were using Kickstarter, but then there were issues with Kickstarter that led to you kind of needed to host your own. And that's what we did for the company I worked at the time, Locatron. And then more recently, I was at Stripe, mostly working on the Stripe dashboard, doing front end. I kind of had like an itch to build something from scratch. So then I spent about a year trying a bunch of stuff. And then and then that ended up being like a game, like a multiplayer voxel world building game in the browser. It was this really, really big game. It got to like around 100,000 lines of code. And then it just got really slow to build, to like do anything. Just making small tweaks was really tedious.
What did you write the game in?
It was a Next.js app. And then just like the UI shell was just like React, but then the actual game itself, it was initially, the first version was, blanking on the name of the framework. It wasn't 3JS, it was Babel.js. Babel build tools. And then I kind of gradually replaced it with 3JS, and then I kind of optimized it a little bit more because I kept running into performance problems because I wanted the game worlds to be really big. And then I started writing a bunch of build tools for the game itself. At first I wrote, you can see this on my GitHub actually, I wrote this thing at build, which was like a kind of macro syntax for JavaScript where you could run like blocks of code at build time and it would use string manipulation to generate more code. And this was used to optimize the voxel rendering for like the actual 3D model generated by voxel data. The build just got really slow. So then I tried to switch out the Next.js app to be like an ES build thing to make it faster. And that was a little bit faster, but then I lost hot module reloading and I lost incremental reloads. And I was like, okay, well, what if I just like try to make that work? So then I went down this rabbit hole of like I had this like Go CLI thing that was like, it used a bunch of ES build plugins and I was like, okay, what if I just like make the server-side running work too? Then I embedded like a V8 isolate to make it work. And then it was like, okay, well now suddenly this is a JavaScript runtime, but like it's using ES build and ES build really wasn't designed for this. What if I just like not use ES build and write my own? And so then I like thought about what language should I use to do that? It shouldn't have a garbage collector. It needs to be really fast. It needs to be very productive for me to actually write the code because there's a lot of code to write. And it needs to be something that also works well with WASM because I really wanted WASM to work well at the time. A little bit less of a priority right now, but at the time it was I thought it'd be really cool. And I think it's something that we'll revisit. And I had tried some Rust before. So I initially was like, okay, I'll try it in Rust. But I just wasn't productive. It was really hard for me to like get a lot done using Rust. And it felt like I was really fighting this compiler a lot, really more specifically the borrow checker. And so I think, so I was like, okay, I'm going to try Zig. Because I'd read about Zig. I saw it on Hacker News, the whole thing about comp time. And I thought that was like the coolest thing I've ever heard in a programming language. And I think that like, just that like, I'll explain. Comp time lets you execute code at compile time. And C++ has like templating, but it's not actually like C++. It's like this other thing. And then like, I think Rust has like macros. Instead of all of that, and C also has macros. Instead of that, you could just execute the code at compile time and the result gets inlined into the AST. And that's like really cool. And that's how you do like types. Like that's how you do like generic types is it's just a function that runs at compile time and returns a new type. It's like a very, very powerful primitive. And it means that a lot of things get a lot simpler. So then I just tried it in Zig. The very, very first version was a direct line for line port of ES Build's transpiler from Go to Zig. This took about 3 weeks, I want to say, before I had something that sort of worked sometimes. And by worked, I mean like printed code that sometimes ran. And that was actually from scratch. Like I'd never written any Zig before. So like it's both it's kind of also a testament to like how simple of a language Zig is, that somebody who's mostly spent time doing front end can just jump in and build a really complicated thing. And it kind of works after just 3 weeks.
Did you run into any big challenges just with like doing basic memory management? So for those of our listeners who might not be aware, I'm going to make a really terrible analogous sort of description here, but like I think of Zig as kind of like C, whereas like Rust is like more sort of like higher level, quote unquote, and feels like more C++ E. That's a really bad analogy, but Zig definitely feels lower level to me in that you're really thinking about like, you know, your relationship and memory management, and you can set up a bunch of stuff to actually tell it how to allocate memory, which I think is really interesting. Whereas Rust is like tries to give you guarantees around the compiler to make memory safe programs. So I'm curious, is like being that Go is garbage collected and you don't really have to think about it as much. Was that a big hurdle to sort of work through?
Well, the very initial version just leaked everything. And for a CLI tool, that's actually fine because you're not running this program long enough. So then you just make sure that you don't use that much memory, which is actually pretty easy with Zig because Zig is very low overhead. There's no string type. It is a length and a pointer. It kind of makes allocating memory a little bit tedious, which has this kind of positive side effect where you try to just do a lot more stack allocation. So in Bun right now, even today, it will try to, it tries to just allocate a really big stack from the beginning. And then that helps a lot with making memory management simple. Just minimize the number of dynamic allocations. So basically what most Bun kind of, this is actually another thing Zig is unusual about versus C, which is very good, what Zig does here. And that is because there's no generic memory allocator, you can just swap in a custom one. So a lot of functions will accept a memory allocator as an argument. And so in the transpiler, the transpiler has a custom memory allocator. And the way this works, and this turns out to be a really good thing for performance, as well as just making a lot of code simpler. It's effectively a bump allocator, which means that you don't free anything, or you don't free anything until the very end of a cycle, and it just sets like an offset. It's like basically you have a big array of like pre-allocated space, and then you just store what was the end of the array that you used, and then at the end of and then when you're done, you just reset it to the beginning. And then in Bun's case, it has just a bunch of blocks, and then it says what block am I in and how much of that block did I use. So then that makes a lot of the memory management stuff. That's used for the AST. And after it's printed, it just resets it back to the beginning. And then on top of that, the second thing with memory allocation is it uses lots of arenas. So it's really kind of, it's difficult if the default way to do memory management is for this type of language is probably more like you manually call free a bunch of times, or in Zig's case, you call dnet, is that's the convention. But what I do most of the time is just have set points in the life cycle of the program where we know it's time to free everything, or that we can free everything. And that makes stuff often a lot faster because the time it takes to free stuff does add up. And it's also a lot less likely to cause bugs because it's so simple. And the only thing you have to be careful of is don't use a lot of memory, because otherwise you're just going to run out. But Zig is already just very good for that.
This is really interesting. So this is very much lower level than I think a lot of people would get building something like a tool like this. Generally, a lot of people would approach it at a much higher level, thinking about just getting the sort of runtime behaviors that they want there. And by choosing Zig, which is a lower level programming language, and by thinking directly about memory allocation and stuff like this, you are forced into all these constraints that, while most people wouldn't think about, you absolutely do pay performance costs in these things, right? It's that's why, garbage collection language gives you the benefit of not having to think about this for the most part, but then you suffer performance penalties at various times, and that may be a trade-off that people are okay with. But I think as we've seen more and more, especially in the JavaScript tooling world, it's performance matters a lot, especially if you're building, transpiling really large projects. So it's this sort of thing is actually really appreciated, I guess, just going through all this complexity. Has this experience changed your perspective of how you approach tooling or how you think about tooling? Just, approaching it from a lower level perspective?
Yeah. Yes. One thing I think a lot about now is, what is the code actually doing? At every, kind of extremely pedantically. And a really tiny example is in a JavaScript context was the subtle difference between object.assign versus dot, the spread operator, or that's not really a good example. A better example is just creating a new object using a literal versus assigning each property individually. You'll find that if you micro benchmark this, and actually you'll find that setting each property individually is quite a bit slower. Even if it's a new object you just created, it's because the prototype is changing each time, and it's because there are all these hidden costs of setting properties of JavaScript objects, because properties can be overridden, because the property name might be an index versus an integer, which then is it. And then if it's an array, this kind of gets into depends on what the engine is. But in JavaScript core, for example, there's an array indexing mode that can have a performance impact if you're using if you're using strings versus if you're using identifiers. Or sorry, if you're using an identifier versus if you're using an integer. And then there's various watch points and things like that come into effect if you you set a getter, if you set a string property, an identifier property on an array, and there's all these like, and so like those sorts of like extremely minute details, like the difference between setting a bunch of properties on an object versus an object literal, are things that I wouldn't have thought about before Bun.
Yeah, for sure. I think that it's something that a lot of people don't think about until it becomes a problem, Or I guess from the inverse is you're building a tool like you're building, like Bun from the very beginning. Performance can matter a lot. But like taking a step back and just talking about Bun more broadly, I said in the beginning, Bun is a very ambitious and expansive project. The scope is huge compared to what people normally take on. So we think about like tools like Dino, which is a runtime and sort of has like this idea of like, I can run TypeScript without, running it through the TypeScript compiler to strip out all the stuff. But Bun itself also manages dependency, it does all the transpilation and it like has all these extra responsibilities. Why, like, what was the inspiration for like packing all these features together? You talked about your game earlier and sort of how your path transitioned, but it seems like taking on more responsibilities just makes it harder to like focus on any one area. So I'm just curious about like how this is developed.
I've been just really frustrated with how slow everything is in JavaScript. And like, I still remember the first time that I wrote any Objective-C and I tried to log something to using nslog, that's like the function. And it was just so much faster than console.log. And this just didn't make sense to me. I had expectations of like how long logging should take, and that just completely blew my mind that you could log stuff to standard out that fast. And I think just like the expectations for performance for JavaScript tooling is way too low. And I think that, and I also think that just the JavaScript is just really important now. It really wasn't nearly as important 10 or 15 years ago, but it kind of like, as the internet became more important and like got serious, JavaScript got pretty serious. But it seems like the tools they lack the same kind of, the existing tools today often lack the same kind of engineering effort that you would see in like tools from like the sort of like tools that are like built into Linux. And I think some of that is like kind of been missing from JavaScript.
Yeah. So your journey through Bun has been like, okay, I just want a build tool, and then you kind of like copy DS build, and then you're like, oh no, that needs to be a runtime. Oh no, now this needs to be everything. So like, kind of, where does it stop? Like, what's your end goal? Like, what's the perfect Bun future? Is every bit of JavaScript I ever run through Bun?
Maybe, or maybe more precisely, it should just be really fast. It shouldn't be a problem. Like build times for anything shouldn't be a problem. And that's also part of the inspiration for Bun install, is that it just took a really long time to install dependencies, and it really shouldn't. And I think it's a similar thing with Bun run, that like Bun run, that like npm run just takes too long. And the problem isn't actually as much npm, or in the Yarn's case, it's not really Yarn, it's really Node. The kind of common denominator here is that Node is too slow. And part of that is also not entirely Node's fault. It's also kind of V8. These things need to start up really fast. And I think that's one of the things that's unique about JavaScript core, is that it both is very, very fast as a just-in-time compiler, but also the startup time is just really good. On the JSC shell, like not Bun, but just the lower level shell on Linux, it starts in like 4.5 milliseconds. That sort of is a baseline. Maybe it's 3.5. It might be 3.5. That's kind of sets like, if I remember correctly, it's like for Node, it's something like 24 ms to do a hello world. And Dino's a bit better than that because they use heap snapshots, or they're not heap snapshots. There's a different name for that, but it's only like a 2x difference.
Yeah, so I think it would be good to drill into the difference here, because it's kind of subtle for people who aren't like into JavaScript so much. You're not using V8, right? Like JavaScript core is like a different JavaScript runtime. Is that how you would say it? Like
It's a different engine.
Yeah.
So JavaScript, so both V8 Node and Dino both use V8. V8 is the common way people run JavaScript outside of browsers right now. V8 is what was used by Chromium, and that's how Chromium executes JavaScript using V8. And you can think of Chromium as also shipping its own runtime, sort of like Node or Arduino or Bun, because like they have the web, except instead of being a server, it has like web APIs. So then Bun uses JavaScript core, and JavaScript core is the engine used by Safari. And so it has a similar sort of, it also has like billions of devices that run it. It's just different. It has a different implementation. And there's a lot of really interesting stuff about JavaScript core in particular. It has this really tight integration with WebKit. WebKit is the open source version of Safari, similar to like Chromium is the open source version of Chrome. And in Safari's case, in WebKit's case, the code, there's a lot of overlap between the code in WebKit and the code in JavaScript core. So, and that's been something that's been really helpful for Bun, because Bun can just import web APIs from Safari in a lot of cases, which makes it a lot more possible for like me to just add web APIs to Bun. And I can, and I don't have to worry as much about like, you know, I don't, because Apple's engineers have already done a lot of the work. And because it's open source, Bun can just include it.
Yeah, so that's why you can have things like Fetch, WebSocket, and Readable Stream all built in, because you're just kind of importing them from WebKit.
So Readable Stream, yes. A lot of Fetch, like headers, is from WebKit. The response and request and fetch function, that's custom, because I probably could actually include it probably should move to be the WebKit version for response and request, and then the WebSocket actual JavaScript bindings are directly from WebKit. So it's sort of like the networking layer stuff is in Bun, but the actual bindings and a lot of the business logic is just JavaScript core. It's still the current version of A to B and B to A is literally copy pasted from Safari. And there are a number of functions like that. Like URL search params is another one that's exactly copy pasted. URL. I was very happy that I could copy URL because there's a lot of nuances to parsing URLs correctly. And it's like, it's so much code. There's like a ton of stuff about in the like handling similarly named, I'm forgetting the name. There's a name for this, but like similarly named URL or similarly words that look like letters that look like the same letter. Unicode normalization, I think that's what it's called. Yeah, there's just NF case, one of those 4-letter, 5-letter NF something acronyms. Yeah, there's a lot of stuff like that it would just be really, really hard to have gotten as far as Bun has without the being able to lean on WebKit for those things.
Okay, that's good. I thought you were implementing everything under the sun. So like at least you're not implementing those things. But you have implemented some like pretty crazy stuff though in Bun. Like you have 90% coverage of an API, right?
Something like that, yeah. And
Could you explain for our listeners who might not know what an API is, what it is, and like why you would want to do this?
I'm going to caveat that it's still like buggy, but the actual functions are implemented. But so an API is the native API bindings for Node.js that let you run native code that is written using the Node.js specific APIs. And so Bun supports that. It supports about 90% of the functions. And for that in particular, that didn't actually take that long. I think it was like a week and a half of work to get most of it done. It's because it's mostly stuff that I'd already written for different parts of Bun, because effectively it's like a JavaScript runtime API. And because Bun is mostly still written in Zig, I had to write a bunch of bindings for the C++ code to work with Zig. So in a lot of cases, it's kind of the same code, just with like a different signature, and there were some nuances to make more of the functionality work in the way it expected. And also the memory allocation stuff is a little simpler with JavaScript core than with V8. V8, you have this whole like handle scopes, and the lifetime is making the garbage collector aware of it has to be bound to a scope, if I understand correctly. And in JavaScript core, what's really cool is it just scans the stack. The way in native languages, you have stack memory and you have heap memory, and they're different things. A stack memory is like a temporary thing that only lives for the duration of a function call, essentially. And heap memory could live forever, or it's like whenever it's done, it's going to be freed. And in JavaScript core, it looks at all the variables you used inside the function, and then it detects, and it looks at if any of them point to like JavaScript stuff, and it'll automatically realize that it's being garbage collected or that it should be garbage collected. And that's really nice because that saves you a lot of code. So that's also part of why it didn't take very long to add it to Bun. Probably the more complicated parts were just like figuring out what all the functions are, what all the corresponding functions are in JavaScript core. JavaScript core is not really designed to be easy to be embedded. Like they don't have like, the docs they have are for the C API, which is fairly limited in what you can do. The C API is mostly designed for iOS apps embedding JavaScript core for like a very small thing, like an in-game, like something that has some code that for like if you have like ads or something. So Bun has to use a lot of the C++ private API in JavaScript core, and that was like a month of just like me reading a bunch of code in WebKit. It's a huge code base,
Can't
and just
imagine.
like, yeah, it was just like going through and trying to like, it would be like, a lot of it was just like, well, how do I even first start a simple application by embedding it? And then even before that, it was like, how do I even embed it? How do I like build it so that way it can actually be included in another application without pulling in all of it? Because like Bun doesn't need to have a whole web browser. It doesn't need like the URL bar, for example. That doesn't make any sense. Fortunately, in JavaScript Core's case, they have like a JSC only port, which lets you take just the parts of that are relevant to executing and running JavaScript. But even then, you're still left with just the C API. So then you have to do a bunch of stuff to use the C++ API. And also, I didn't really know C++. I still don't really feel like I know C++.
It's definitely a non-trivial language, and it's grown so much. So I did C++ in college, and I haven't looked at it a lot in many years. And now I go back and look at some of the new specs, and I'm like, oh my god, it's like there's a lot to it.
Yeah, I think there are some things I really like about it, though. I like that you can have multiple functions with different types in the signature, but like the name being the same. I don't. There's probably some specific name for that. I don't know it.
It's like function overloading.
Maybe it's kind of seems
more complicated than
I
that?
feel like it's probably more complicated because it's not like when you extend it's not like subclassing. It's like you can have the same function name but it just accepts different arguments. So then you have like if you have like specialization. It's something like it has the word specialization, I think, in the name. Like I think that's a cool feature, but I still just like Sake a lot more. The thing that's interesting with C++ is that you can just do a lot of stuff and it's really hard to find out exactly what's happening. Like because the specific thing is like, because you could have code that runs in the constructor and in the destructor. That's like a huge source of hidden behavior that will just quietly make your code run slower because you forgot that like this function is being called, and there's like 4 levels of nesting, and like you're doing like an atomic lookup for every you're like reference counting, and then that's like an atomic integer or whatever. None of that exists in Zig because Zig doesn't have those kinds of abstractions, which is a very good language design decision. It makes something more complicated, but sort of for this type of product where it really needs to be fast at everything. It's important. That's the right trade-off.
Speaking about being fast about everything, something that's very common with JavaScript build tooling is plugins. And plugins today are mostly written in JavaScript for like Babel. And porting that to Bun would mean your plugins are slow, and now you have this new source of slowness. Do you plan on adding plugins to Bun? Because like you have like a CSS thing going on, you have a bundler, like you have a transpiler. It just seems natural that like maybe plugins would come at some point during that.
So this is just not documented yet, but this already exists.
Okay.
And I think it's going to like be something that people are going to really like once it's a little bit further along. But it does work right now. But so basically the idea is, I was talking earlier about comp time and Zig and all of that, and the same thing but for JavaScript. So the idea is that sort of something like the implementation is a little bit like Babel macros, except instead of having like a DSL that you have to learn in order to like convert from like arrays to what like the AST version of arrays, Bun just does the automatic conversion. So you just call a function at build time, and Bun will return the object that you return, or if it's a primitive, it gets inlined into the AST and is replaced with the function call. So it's like a really simple way to move code from runtime to build time.
So are the plugins written in Zig?
JavaScript.
Oh, they're written in JavaScript.
This was actually a big reason why I chose to embed a JavaScript runtime in Bun, because Bun didn't start as a runtime. Bun started as a bundler and transpiler. This was something that just would seem sad about with other native transpilers, that suddenly everybody had to like write all their plugins in Rust or in Go, and like there was this trade-off in the ES build case. There's this trade-off if you benchmark the JavaScript plugins, they're not very fast, and it's kind of this constraint of using this IPC protocol of not having low-level control over how the JavaScript executes. So I think in Bun's case, this is just not going to be a problem. But the constraints are going to be different. The way this works right now is it doesn't give full AST access to plugins. It gives AST access to the scope, to like, if you call a function, then it calls the function with the AST node, which is the call expression. So then that includes like the function, it includes any of the arguments. So it's very much like you're calling a function at build time, but you're getting the AST nodes instead of the arguments. And then those arguments can also be coerced to the native type, to the JavaScript type. So like if you're passing a string literal, then you can get the value as a regular string. Or if you're passing an object literal, you can convert that into like an object. But if you're passing an identifier, then you're getting it as an identifier. And that identifier in this case is an AST node.
Yeah, that's interesting. That sounds a lot like Rust macros, or I guess maybe even comp time. I can see the inspiration there of those underlying systems. Because I mean, typical JavaScript tooling where you're like taking a blob of text and then converting it to an AST and then passing it to many functions that like transform it over and over again. Like the whole thing is obviously slow and wasteful, but it gives you a lot of freedom and flexibility to do like very crazy things too. So, the interesting trade-off. I would love to see what that looks like, because it sounds really cool.
Yeah, there is an example in Bun's repo. There's a few examples. I need to actually like write the real docs. It's just a really long readme right now, and that's definitely not good enough. But the example is, if you go to packages, there's Bun macro relay, and that's like a relay plugin that uses these macros. And in that case, the macros actually have two different ways to use them. One is you can just return object literals, and then you can also use a custom JSX transform. And the custom JSX transform, just for macros, that lets you have things include AST nodes which are not representable through like object literals and arrays and things like that. So in the Bun macro relay case, it needs to inject an import into the top of the file. So it does that by using the JSX tag, like import. But then you pass it a path, and this works because Bun, when it has like a macro mode in the JavaScript runtime, which is turned on by the transpiler just before it executes the macro, and that enables this other JSX transpiler, and then there's like a serialization format for like converting the AST schema and the AST nodes into JavaScript and back.
That's a lot of hoops. Yeah.
Yeah, it is a lot of hoops. It's actually but it's pretty efficient. It's the actual data format is basically a big array with a bunch of numbers and some strings. And I think that like once this becomes more used, the issue really, this is like, I think it needs to be tested a little bit more and like have some people try it, because it's mostly like ideas in my head and not enough like building things with it. There's like a few examples in the repo there. Like there's one that's like fetch a CSV at build time and from like a URL and get just the results into the build. So then like you could do like in that specific example, it's like you statically render a React component, but using remote data, and it's sort of like if you've ever used like Next.js, it would be sort of similar to like get static props, except instead of only being in the page, it could be literally anywhere in any file. And then And the other neat thing about doing this stuff at build time, at comp time, really, is like it enables a lot of optimizations for the transpiler and for like dead code elimination that are just not possible in any other tool because it can detect. It actually inlines the result of what you call, and it does this recursively. So if you get a big JSON object from like the GitHub API or something, and you only actually want the username, then it's going to only include the username in the output. And that can be like a lot smaller than the entire JSON object in how you would do it normally. And it'd be pretty hard in a lot of cases for a tool to do that because the minifier or whatnot wouldn't know. It wouldn't know that like those are side effect free and that like you're only ever going to be able to access this one thing because there are various constraints. But because this operation happens at build time and because it's all like one cohesive thing, it's possible to make this really fast while also making the code, like make these macros run really fast while also making the code smaller. And they run fast because they don't get access to the whole AST. They only get access to the part that they actually care about.
Yeah, yeah, that's definitely the big thing, and I think that's a lot of the problems that we've had with, a lot of tools, Babel, PostCSS, which I think PostCSS might be trying to take a little bit of a different tack now. But like, if you just give the whole AST to a function that only cares about like two or three things, then it like is inevitably slow, especially when you run it over an entire code base.
Yeah, and when you run it multiple times, because when you have to run in for every single plugin, like that's a problem.
Yep, totally. It makes any performance problem that you have at a baseline of just a single plugin just explode because you're like multiplying that by n plugins. This is really awesome. I think one of the most challenging things with like any meta programming or macro system or whatever is like the happy path is great because it's like you get to do complex things and with simple like end user code, but like when things break or stuff doesn't work, that's always where it's really hard. It's like understanding that this thing is broken because of some macro code and like trying to trace that sort of thing. It's like it makes your implementations a lot more complicated, and error handling and all that stuff can be hard. So, but it's really cool to see.
Yeah, the error handling part is mostly reuses the existing error handling for the JavaScript runtime parts. It just turns them into build errors.
Nice.
There's like a global like log essentially, which is a distinct log from like standard out that is structured as like a bunch of build errors or resolve errors. And because Bun transpiles every file, even like node modules, even regular JavaScript files, it has these. It always has this build log, and then depending on how the code is run, that build log will either will throw build errors, which I think it's literally called build error in JavaScript, that you like if you do like a dynamic import to a file, then and that file fails to transpile, then it throws a build error. Or if it's at the very start of the application, then it just logs it. And then if you do like console.error on the build error, it prints it the same way. Like the console functions are like detect that, oh, you're printing a build error. I'm going to print this using the special build error format.
Nice. That's awesome. Yeah, it's really cool how you detect the context and sort of take care of things in so many situations. Whereas in a lot of other, like if you're doing other tooling, it's like you have to be very aware of your context and like do a lot of extra effort to, map things. And that can make consistency in tooling really hard because you can have like 3 different plugins trying to log in different ways or whatever. That's really awesome. I kind of want to just like step back a little bit and talk about like, so Bun, we've discussed, very ambitious project. It like does a lot of stuff. There's like 2 things that I'm wondering is obviously this is a ton of work and it seems like you might be building up to something. So the first question is sort of like, what's your end goal here? What would you like to do with it? And then my sort of follow-up question is like, do you have any plans on really making it sustainable? I know this is obviously a ton of work for you. And as we've talked about a lot on this podcast, open source stuff can be hard to monetize, but your time is very valuable. This is really, really hard work. So yeah, maybe so just starting, what is sort of the end goal? What are you wanting to do with Bun?
I think Bun, there's this, we're sort of entering the past like 5 or so years, JavaScript has kind of the syntax and like the tooling has sort of started to stabilize a little bit more. Like in contrast from like the ES6 time, around that time, where like there was a bunch of ton of new tools and new ways of doing things. And there's like, there's a couple of newer things coming out, like the match. That's not exactly the right name for that, but there's like two recent proposals that are like records and tuples, and then the match one, I'm forgetting the name.
Pattern matching?
Yes. Those will probably change the syntax a lot. And then maybe the optional types, but it seems like it's kind of somewhat stabilizing. So I think there's going to be a consolidation of JavaScript tools. I think that's kind of inevitable, and everything's just going to get like a lot simpler if you have fewer and tools that do more. But I also think a prerequisite of that is it needs to be really fast. And consolidation should enable tools to be faster because you can share more of the data together. So like in Bun's case, the TOML parser and the JSON parser use the same AST. And that means that that's like more efficient from like for many reasons. But one is that if I optimize the JSON printer, that also makes the TOML print faster because they're the same code. But I think, so basically, I think Bun has an opportunity, there's this opportunity for like an all-in-one tool that does that fills a lot of the roles of existing tools, and it will just make everything a lot simpler for like day-to-day stuff. And I think Bun has a good shot at being that tool.
I really only see two players in the space right now. It's you and Rome Tools. Like you guys, like you're not approaching the problem in the same way, but like it's kind of the same end goal of like unified JavaScript tooling set that's also fast.
I don't really know about Rome that much.
Okay.
I don't really work on Rome.
Yeah.
I would say it's almost different though, because so Rome, their goal is to have this. And for listeners who might not know, Rome is like this all-in-one tool set written in Rust that tries to re-implement linters and pretty printers and basically all the JavaScript tooling from a very similar setup. But I don't think a runtime is in their wheelhouse. That's not something they're trying to do. And at the same time, you have Dino, which is a runtime for JavaScript, also written in Rust. Ryan and crew are sort of focusing on improving on what the foundation that they'd laid in Node and trying to make better decisions technically and make that faster and everything. But the crazy thing for me is Bun seems to be a combination of these two things. It's that you take Rome and you take Dino, which are both huge projects. You lump them together.
And both with VC backing. Like you're a one-man shop. I guess the real question is, do you plan to like make Bun more of a community driven project? Do you plan to get VC backing at some point? Like you can't do this all by yourself forever.
Yeah, no, it's impossible to do all that I really want Bun to do by myself. And I think that like Bun is going to be a company, and we'll hire people, and people will help. It won't just be me working on Bun. And I think this is going to happen pretty soon. It's been really, really cool seeing the reaction to Bun. I spent over a year just kind of in this room writing lots of code. And I think that it's just really gratifying to just see, like, we got like, Bun is at like 25,000 stars on GitHub now, which is just like, seems like kind of insane, especially when it's so early and when like so much stuff doesn't actually work super well yet. It's very much like like Bun install is really fast, but there are all these things I need to fix with it. There's like a few crashes that are not good. And then like, it's just very early, but people still seem to be really excited.
Yeah, usually the order is make it work, then make it fast. You seem to be kind of doing the opposite of make it really fast and then make it work.
Well, it's more like doing both at the same time.
Okay.
And I think it has to be fast. Like the speed has to be prioritized from the beginning because it's so easy to build a slow thing and so like the only way to make it fast is you have to focus on it from the very beginning. And you have to also just like benchmark a lot. I spend so much time just benchmarking stupid things.
What's the stupidest thing you think you've benchmarked?
This is like a subtle, this one actually had some impact though. Basically, so Bun text encoder, like the text encoder class, it's really fast, but if you compare it with Deno or Node, if you compare it with Node, it's like I think it's 10 times faster, but I'm sure somebody will double check. If you compare it with Deno, I think it depends on the type of string, but if it's a Latin 1 string and it is not a rope string, I can explain what that means in a second, then it is usually, from what I remember, it's 2 times faster. And this was after some back and forth where like they saw that Bun's text encoder was faster. So then they're like, we got to speed up our text encoder. And the reason part of what made Bun's text encoder really fast is this micro optimization where I spent a bunch of time figuring out, okay, how do I, like when you to do a text encoding, to encode from Latin 1 to UTF-8, Latin 1 is the default encoding in most JavaScript engine. You have to, you basically need to find all the characters, all the letters which are greater than or equal to 127 in ASCII. And then if they are, you do some stuff to convert them. But the slow part is how do you quickly find the character that is greater than or equal to 127? The really naive way, which is the easy way, is you just do a for loop and you say, okay, does this character, is it greater than 127? And if so, you do the encoding stuff. The slightly faster way is you use something called simd. And this is a tool that's not really available to JavaScript. It stands for single instruction, multiple data. And it's a way to tell computers, it's a CPU instruction, it's a bunch of CPU instructions, it's not one, where you can pass it, you can, instead of operating on one number at a time, you can operate on up to, it depends on there's like various differences between like CPU architectures and when supported features, but usually in Bun's case, it'll read 16 numbers at a time, which are 16 characters in a string, and it looks at which, if any of those 16 characters are greater than 127. So that's like that was like the first optimization for like it's like how do you find a number bigger than 127 really fast. Then the second optimization after that was once you do find it, you also need to find the index of which of those 16 numbers are less than 127, because you need to, or greater than 127, and which is the first one, well, the lowest one, because it tells you, depends on how you use it, but the easiest way to use it the most straightforward way to use it is you just find which, if any, if it has any non-zero values. So then, but there was like a bug I think it's like an LLVM bug. LLVM is like the compiler used, that is like Zig is a compiler, but Zig has a compiler, but it also emits LLVM IR, which is like, and then which is like the language that then gets converted into like assembly. And so there's like an LLVM IR bug that causes it to emit, if you're using this simd and you're in this way, and there's like an efficient instruction dedicated to just counting what was the first number that's not what is the first bit set. Or it's count trailing zeros and there's count leading zeros. And these in JavaScript, the function is math.clz32, which is just like a weird acronym if without the context, or like a meaningless acronym. But basically, it counts the leading zeros in the bits. But there's some LLVM bug that was like causes it to be, if you pass it for the simd vector, it causes it to count, to effectively do a for loop, and it does it like using the non-sim scalar way. That's the name for the non-sim scalar. I'm probably mispronouncing that. It's not a word. It's a word I read, but it's never a word I really say aloud. There's a lot of words like that in programming.
Very true.
So the micro optimization was basically just getting the max, checking if the max is greater than 0, and then using a different technique, simmed within a register, swar. I don't know how to say that. And then basically doing a similar sort of thing as what you would do with simd, but without any of the simd parts, just with like bit shift operations. There's a few different blog posts on this that are pretty good. Basically everything that like, I don't know how to say his name, Lemire, Lemire, everything he writes is really good on performance. So yeah, that was an example of like this wasn't a stupid micro optimization, but it was like, it turns out that it's actually really complicated to correctly, to like as efficiently as possible, find a number that is greater than 127 in an array. if you want to just like be really obsessed with making it fast.
Which you are.
But there's actual real performance like gains from this. It's not just like micro benchmarks. It's part of why Bun is like 3 times faster than Node at server-side rendering. It's because it's like that actually turns out that's mostly a text encoder thing. That it just has to spend a bunch of time converting the text from Latin 1 or from UTF-16 into UTF-8. So if you can count which number is greater than 127 really fast, you could make React server-side rendering much faster.
That conclusion probably took you hours upon hours to come to.
Well, in this particular case, it was I did the text encoder optimization stuff well before I focused on React SSR. But the React SSR part, it was I profiled it a bunch using instruments, and then instruments was like, here are the functions that are taking a long time. So then I was like, okay, how do I make these numbers go down?
Yeah, it's interesting. You're working at a much different part of the stack than I like any front end people. So like the way you view these problems is very interesting. I have one last question before we move on to tooltips. I saw a tweet where you talking about like kind of like the future use cases of Bun and like doing per client bundles on the edge. Like that kind of sounds like a bunch of word soup to me and probably to a bunch of our listeners. Can you explain like what that idea is and like yeah, just explain that.
Well, it's sort of what I was saying earlier about macros. You could take the same idea and basically today you have today the way build steps work and for a lot of front end code bases is you push to production or you push to Git and then you have some CI step that runs Webpack or whatever on the asset and then you serve the same asset to everyone. And then you have a CDN that caches it. The direction I think would be really interesting for Bun is what if you build a unique JavaScript bundle for each user and you had like an API and sort of like hitting the importing the JavaScript is sort of like hitting an API endpoint, or you have like some dynamically generated data and inside the actual printed source code. And the result is that a lot of code could get a lot simpler because a lot of the complexity of writing front-end JavaScript is how do I manage getting the data? How do I manage the state associated with the data? And even if it's just a pure static data, you still have to have like a serialization library. You have to worry about like type safety in a lot of cases, and you have to worry about like even if it's just static. But if you could actually just make it so when the user imports the code, or like when the code is loaded, if it already has the data inside, it gets a lot simpler. You don't need like a library then. You just have a function that's called at build time, and that build time happens to just be the HTTP request. So then what's missing is how do you actually pass that context into the macro? How do you pass that context into the function? And so then that's like a thing that it's like an API that the transpiler needs to expose. But if you can get access to the request data, if you can read the URL and read the headers, that's enough to just like make some database calls and then inline the data directly into the file. And then suddenly you have really good dead code elimination because you know exactly what parts of the code they're using. So you don't need a whole data fetching library. You don't even necessarily need to, it might not even include the entire object that you're returning from the database. It might only include the exact fields that you're referencing. So it turns into both a more efficient, it turns into like less code that you have to write while also being less code that runs in the browser. So the thing loads faster. Of course, the trade-off is now you have to run this code. You have to generate new JavaScript bundles or at least new individual components or something for each user. And the only way to make that actually work is it has to be really fast because otherwise it's going to just make it way slower because, and so this is like the type of thing that's really only possible because Bun is a transpiler, a bundler, and a runtime all in one.
Super cool.
That's crazy fascinating. So Facebook had this project, and I was trying to look for the name of it now, where they tried to take your code and do some like early
pre-pack.
They would try to execute it. Yeah. They try to execute it, just like run it and transform things. So it's like you had some static code that like took a static array and did a lot of operations on it or whatever, they would like run it through there and it would like just spit out the result. And that's the final result was what you would send. But this is like so much crazier in that the actual complexity of this is probably much, much lower. Because I mean, they had this tremendously complex problem, and like doing early execution of programs and trying to figure out what they can serve, or whatever. But the actual complexity of this is much lower. It just like the question is, can you get it fast enough to be able to serve what you needed to serve? That's super fascinating. I really love to talk more about that sometime.
I think the long term there is you really need a hosting service to make that work, and that's also
I see where that's going.
Yeah. So that's kind of the direction I'm thinking about with Bun.
That's super cool.
That's
Awesome. With that, let's move on to tooltips.
What did you say the name of the tool was? It's what?
Prepack.
Facebook's tool?
Prepack.
Prepack. Yeah.
Yeah, it's a cool idea.
They stopped working on that, right?
Yeah.
Yeah. It's too bad. I mean, it makes sense. It's a fiendishly complex problem.
Yeah. I think they
feel
stopped
like
working on it quickly.
Yeah, I feel like it would just be very hard to define like what it could do or how to make it like consistently work.
Yeah.
Oh, this is cool.
Totally.
I hadn't seen this before.
Yeah, so my first tooltip of the week is my new Git client. So over the past like 6 or 8 years, my main Git client has been using GitUp, which is a very visual way to visualize your Git repo. It's basically this tree part of the client, but that's the entire Git client. But unfortunately, it's an open source tool that's maintained by people that aren't paid, and the performance has just gone to shit. And in my work repo, which is like 50,000 commits, it just like it chugs to a halt to do any operation. So I set out to find a new Git client that I wanted to actually use, and I've been using this one for about 3 weeks now, and I gotta say it's very good. And what's funny about it, it's like it's built by like a couple, a husband and a wife, who just put it on GitHub. And then I found an issue where people were like begging them to be like, hey, take my money. I want this to keep going. So like it does cost $50 now, but it's like the Sublime model of costing money, where it's like, I'm just going to annoy you every N amount of times you do something. And if you're looking for a new Git client, it's very fast and very easy to learn. So check it out. Has a lot of cool features in it. The really cool feature, though, is this rebase feature. It brings up all the commits you're rebasing, and you can just like say if you want to drop them, squash them, merge them, reword them. Very nice.
Nice. This is an actual tip. Did you know that you can have a QR code that is actually like a Wi-Fi access? So special format of a QR code. I didn't know. There's this blog, and I think I saw it on Hacker News probably. It's jgc.org. We'll link the blog post in the show notes. But yeah, it's just that. You can I didn't know that there is a special format of QR code that is just like Wi-Fi access. So like I guess all the phones that support this, you can just like point it at the thing and set up Wi-Fi access.
Yeah, I think this works on both iPhones and Android phones. Something that Android phones do a little bit better, though, is you can store this same thing on an NFC tag, and on an Android phone, that'll like automatically like log you into the Wi-Fi. It doesn't work with iOS, but hopefully someday.
They'll get it eventually.
Yeah, 5-6 years after it's a cool thing.
Yeah.
Now we got the awesome Bun repo. What cool things have you found in here, Jared?
Like one thing that Bun hasn't implemented yet is child process, but in Bun utilities, somebody implemented child process using NAPI, using Node's native bindings.
Oh, wow.
And I just think it's like really cool that like Bun has been public for like less than a week and people have already started writing all these libraries. Or not less than a week, it's been public for just over a week. And there's actually more than this. They're just not on the repo yet. And I think it's just really cool that, like, honestly, I just think it's cool that people even want Bun. It's just very gratifying that like, I've been working on this thing for a year and just people seem really excited.
Yeah, it's definitely a cool thing. Like, you've probably dedicated thousands of hours of your life to this at this point, and that like it's just getting such wide acceptance is pretty cool. For a while there, were you like you had like a closed beta going, or like a sponsors only type thing going?
I've actually never accepted any money for Bun. I've just been living off savings. I had a private beta, but it was like kind of like the way it worked was you would go to the website, you would click request access, and then it would take you to Bun's Discord, and then you type I want Bun, and then the bot would send you an invite link to the GitHub repo. So at the time of launching publicly, there was already like 4,000 people in the GitHub repo, and that was just because it was in this like private beta for a while. I think it's really important that Bun did a private beta because it's just so much scope. And honestly, like I should have just tested it more before shipping it publicly. It was kind of random. Excuse me. It was like I just felt like if I waited any longer, people would think it's just vaporware, and that was just never going to happen. So then I was like, okay, I'm just going to choose a date that's not tomorrow, and then I chose like July 5th because it was the day after July 4th. And it wasn't tomorrow. And I knew I needed at least a week to prepare stuff. And honestly, it's still not really prepared, but it's going well.
You got to put it out at some time. And congratulations on the 0.1. Like it's a big milestone, and you can't wait for that 1.0.
Yeah, for sure.
There were 83 versions before that, or at least the build ID was 83. Like you can go back in Bun's repo and you'll see a lot of versions. You can see the first one with the macros too in there. And I actually did there's like when I would write the release notes, it was like a lot of screenshots of like.
What's the old adage? It's like you're supposed to release it before you're ready, or release it before it's ready, or whatever. Just like make sure you get it out there.
Yeah.
Yeah, we don't want Bun to die on a hard drive. One question about the name though. Well, was it just because of bundling? Like, where does Bun come from?
So this brand has a bunny named Bun.
Okay.
and I was like, no, at first I was like, no, I'm not going to name this after your bunny. And then I thought about it more. I was like, oh, that's actually like a pretty good name. And so then originally it was like Bun, like a bunny. And then my friend got this, made this logo that was like a bow. And then I was like, okay, I guess it's bread now.
Well,
Then you have the bun commands,
Yeah.
which I think is amazing.
yeah.
I like
all
it,
worth
but it's also confusing is the problem. I like it, but it's confusing. But because I think when you repeat that you have to say bun, people are like, wait, I run the same command twice, or I say the name, or like I type the name twice. Like it's very hard to explain in documentation. And then people are like, what does that actually do? It just sounds like those are just like meaningless words. But I think it quickly makes sense once you run it. It also kind of needs to be done a little bit differently. I have a lot of thoughts on like what the bundling format itself. I want to do like single file deploys. I think that's going to be a nice thing. So that's all that stuff's gonna change a bit.
Well, I think you should add a command bun that prints out a bunny.
I mean, that's doable. That could be done. It's because it has to be a file after that. So then it would otherwise error. So that'd be like a fun Easter egg.
Yeah. Okay, my last tooltip for this week is the player. This is actually on our third episode. We talked to some of my former coworkers from Intuit, and it was about this project, and it just got open sourced the other day. So what the player is a way to author like applications or pages from a backend that render natively on multiple platforms. So what that means basically is you can return this from a backend saying that you want 2 pieces of text on a page, and then that gets sent down to your app, which can be a web app, a Swift app, or an Android app, and those apps choose to render that JSON natively. Why that's really cool. The biggest thing to me is that, say if you want to like create a new screen in your app, if you want to deploy that through the normal iOS process, you have to go through a whole new app store release. You have to get it approved. Could take a long time. If you're using something like this, all you have to do is return JSON that your application understands, and then voila, you have a new page in your app. So if you've ever wanted something like this, many people probably haven't, but I'd give it a good look, because me and my coworkers had been working on this for like 4 or 5 years. So it's come a very long way, and it's very, very battle tested.
That's really awesome. Yeah, don't wasn't it Airbnb or somebody big was like doing that same sort of thing? It's like views driven by data.
Yeah, there's a few like JSONet was like the first big one, but I don't think that exists
yeah.
anymore. Yeah, Airbnb has one, but yeah, it's a good option.
So my last tool tip of the day, I've been working on my website and I had Obsidian Notes, Obsidian, which is this note-taking app. I had Obsidian Notes embedded into my site and I was paying for their subscription thing, and I disabled that because I wanted to do some custom stuff with rendering, etc., etc. Rendering Obsidian Notes, there's a lot of stuff that goes into it, and I found this library. It's called Perlite. I'm not sure exactly how to pronounce that. Perlite. Anyway, so it sort of does what it says on the tin. It renders Obsidian Notes. And so it's a library where you give it your Obsidian Markdown and give it the metadata. There's an extra plugin that you can use to like collect all the metadata for what all your files are linked together. And yeah, it just renders everything out on the web. So if you want to host your own Obsidian Notes in a custom way, this is a great way to do that without taking on the complexity of re-implementing the front end of Obsidian, which I assure you is non-trivial.
Yeah, especially when you start getting to the graph rendering.
Oh yeah, for sure.
Okay, that's it for our tooltips for this week. Thanks for coming on, Jared. This was a much lower level conversation than I think Justin and I were anticipating happening, but it was super interesting.
Is that cool?
Very welcome.
Oh, very welcome, yeah.
And very, very interesting. Yeah.
Yeah, I had fun.
Yeah. Thanks so much for coming on. And just, I mean, I can't even express how impressed I am at the project and the sheer amount of work that you've put into it. And also just appreciative because, so you made that comment earlier about how you focused really heavily on a micro optimization to text encoding. And then the Dino folks was like, oh crap, we got to like make our stuff faster. That's the sort of things like, the rising tide lifts all boats. So the effort that you're doing here benefits the entire ecosystem, whether people are using Bun or not. And from everyone in the ecosystem, I just say, thanks for all your hard work. We greatly appreciate it. Yeah. And good luck on the future.
Thanks.
This is the end of our last free only episode. So truly thank you to everybody who has listened and joined us on this journey so far. We hope you can be along with us in the next chapter too. Make sure to follow us on YouTube and where you subscribe to your podcast, and to go on Patreon and potentially be a subscriber. If you want to support the podcast even more, we could always use more reviews on podcasting platforms. It helps the podcast a lot. So if you don't want to subscribe to Patreon, or even if you do, please go review us on all of those platforms. Thank you.